Hi, also welcome to today's tutorial. So today we will cover the scaling factor. So let me go to the header file in the mActor and we will duplicate this and we will name it as mscale and everything will remain the same. Alt enter and generate definition. So first thing which we will do in the scaling part is to convert this vector in the mscalar format, mvector format. So const mvector vect mvector is equals to vector dot to vector. Okay, so we have converted our vector. Now, when the scaling works, so how the scaling works, let's see how we can do that. Let me give you a matrix. Give me a second. So this will be our scaling matrix, and this will be our main position x, y, and z. Y and z. And this is our identity matrix. Identity matrix means the horizontal value will be 0 and all other value will be, sorry, the horizontal value will be 1 and all the value will be 0. So when you will multiply these two together, the resultant will be, it will be xyz only. So it is 3 by 3 and it will be 3 by 1. This is 3 by 1. So the net after multiplication, the matrix will be of 3 cross 1. This we have covered in the multiplication part. Yes. So let's imagine if I do, so when you will multiply, so it will, one will be multiplied with x, this one will multiply with y, and this x will be multiplied with z, right? So here's the task for you. What if I do want to multiply, like, or I want to have I do want to double the x-axis, what you will do? You will just do 2 here and everything will remain the same. So the net matrix will be 2, 0, 0, 0, 1, 0, and 0, 0, 1. Now, when you multiply it, this time the net matrix will become 2x, y, and z. This is how the scaling works, right? So let's imagine if you do want to scale something in the x direction and y direction, but z should remain the same. In that, what you will do, you will just put 2 here and everything will remain the same. If you do want to scale it in some direction with some value, so you will just put that value on. Okay, now we will see the implementation part of it, how we can do that together. Okay, so in the scaling, first we have to define uh, that matrix. So let me copy paste that for you just to make it easy. Okay, Alt Enter matrix. Perfect. So here I am defining a matrix. So the matrix which we made, it was the horizontal matrix, right? So it was 1 1 1 in that sense, but here if we do want to scale it in x direction, so we will put it 1 0 0. So it will be 1, it will be 0, and it will be 0. And if you do want to scale it in x, y, or something like that, you can just put that factor. Now we just need to multiply it with our position vector. How we will get the position vector? So we need to convert the position vector into the matrix also. So const auto position matrix get vector location dot to vector dot to matrix. Okay, we haven't created to matrix function. To matrix matrix. We want to create that function. Alt enter, create that definition. To matrix matrix. Forward declare it. Alt enter, journey definition. So in mvector, I am creating a function called toMatrix. What it will do, it will create a matrix of 3 by 1 whenever we are creating a matrix with the vector. So return. So here we need to define a float value matrix value, the pointer equals to uh, the value will be x comma y comma z and row and column. Yes, so return. So this is how we were defining the matrix. So matrix value comma row will be 3 and column will be 1. Alt enter, generate definition. Perfect. So now this should work fine. It will be a constant. Perfect. Now get back to our M vector. Okay, so let me reiterate what we have done here. So here I have taken a identity matrix, but instead of one, we so it's a horizontal matrix, and instead of one, we are taking this vector, which we have converted with the M vector. Now we have the position matrix, so we are just converting the F vector to the matrix. Once these two are done, so we just have to multiply them together. So it will give you the const auto result scaled matrix is equals to, so we will multiply the scale matrix with the position matrix, and this will give you the scaling value. Now we have to convert the matrix to the F vector. So set actor location. We know actor location takes the F vector. So first we will convert the scale matrix to, okay, we need to convert the scale matrix to F vector. We don't have direct function. So let's define that dot to M vector. We know like in M vector, we can convert our M vector to F vector. So we will do this function. So generate a definition. I want to create a new one. Alt enter, generate definition. Okay, so return. So here matrix, we know like in array it is like 0, 1, 2. So we will just put the uh, the value at 0, the value at 1, and the value at 2. So value 0, comma value 1, comma value 2, and it will give you the F vector. Okay, actually we do want a M vector, not F vector. Control R. So instead of this, we will do this M vector. No, cancel. It will be M vector. M vector, power declare, M vector, alt enter. Perfect. Now let's see. Dot to F vector. We could have converted directly to F vector, but the reason is like we are creating our own class, so that is why, and we already had that function inside the M vector, so that is why I'm just converting our matrix to the M vector first, then we are converting to the F vector. If you want, you can directly have one more function to F vector inside the matrix also, and it will do the task for you. Like instead of 2 M vector, you can also have one more function. Okay, and instead of this, it will be like this. So let's check if it will work fine or not. Blueprint, let me compile this again. Okay, so instead of a matrix, it will be scale. And we do want to scale it, make it 25 only in X direction. Like what if we do want to scale it in all the direction? Let's see how will it look. Okay, this is something funny. Okay, let's check what we have done wrong. There is something wrong for sure. So let's check. Okay, let's do one thing first. Instead of this, just put 1, 1, 1, and 1. So it should remain the same. Let's not debug it. Okay, this is perfect. Let's put 2. Let's check. Okay, I think it is working fine. The only reason it crashed is like it was in the while loop and it is actually growing again and again. So we will test that in the begin function and we will see if it is working fine or not. Okay, now instead of like tick function, we will use the begin play function and we'll see, and it is working fine. Perfect. And in tick function also, if you do want to put tick, what you can do instead of 1.01, copy, and we will do it like this and we will see if it is working fine or not. And we can also put delay. I know it's not a good practice, but just for testing, and it is working fine. So after every 0.2 second, it is expanding. Let's have the top view and you can see this is working fine. So if you will uh, make a circular, let me copy, Control Z. No. Just to have the visualization correct. 3, 4, 4, and 5. Let me duplicate it. Okay. I think this should work fine. Instead, okay. Perfect. Now you will have like better understanding while it will grow, and if you will translate it also with the scaling in Z, it will look good. That's what I think. Let's see. Let's check if it will. Let's translate them in the Z direction and also 0.05. Let's check. Okay, this is working fine and they're actually going up in the Z direction. I hope this makes sense and all the calculations which we are doing, I hope you are understanding them. If you have any question, let me know in the comments so I can help you together. Thank you and have a nice day. If you are liking this series, if I'm able to help you at all, just do like and do subscribe, do share. Lots of share, I do need that. And thank you and have a nice day. You can also help me on Patreon. Bye bye.